Today I'll be taking you through cache memory. Now you may ask yourself, what is cache memory? Cache memory is a type of high-speed computer memory that provides high-speed data access to a processor and stores frequently used computer programs, applications, and data. So it serves as a buffer between the CPU and the main memory to improve data access times and overall system performance. So I'll be taking you through mapping functions as well as something else we're going to see in the future. So cache memory typically speeds up operations by working with main memory to achieve the processing needs of the computer user, like I explained earlier. And mapping functions are needed to enable the two to work together, since cache has fewer lines than main memory blocks. So we commonly have three approaches: direct mapping, fully associative mapping, and self-associative mapping. So starting with direct mapping, each block of main memory is mapped to exactly one specific block in cache. Also, it's the simplest and most efficient since it's easiest to implement. And that's its mapping function. Cache index represents where the index where the data is stored in the cache. The main memory address, the address to which the data you want to access is within the main memory. The number of cache slots represents the total number of slots or entries in the cache. Then for the associative mapping, each block of main memory can be placed in any cache slot, allowing for maximum flexibility. There are no index bits. Instead, the cache controller searches the entire cache for a match. Also, this is more complex and slower due to the search, but it eliminates conflicts. So overall it's a better mapping algorithm than direct mapping. Then the last one, which is set associative mapping. This is a compromise between direct and fully associative. So the cache is divided into sets, each containing multiple cache slots. And each main memory block can be placed in any slot within its corresponding set. And there goes its mapping function. Cache index is a particular index in cache where the data is stored. Main memory address is the address of the data I want to access in the main memory. And then number of sets is the total number of sets of slots in the cache. So the number of slots in each set can vary, like 2-way, 4-way, 8-way, depending. Then, other than mapping functions, I'm also going to discuss replacement algorithms. So when the cache has been filled, a new block is brought into the cache and one of the existing blocks must be replaced. And these algorithms typically apply to help us to replace the current block in the current data in the cache. But you should note that this doesn't work on the direct mapping. It only works on the set associative and associative, since the direct mapping only has one possible line for any particular block. And then also for efficiency and speed, this algorithm should be implemented at a hardware level. So we also have three most commonly used: list, recently used, first in, first out, and then list, frequently used. So how does list, recently used work? List, recently used replacement selects the entry that hasn't been used for the longest time. It is based on the principle that items must have been used recently. That items that haven't been used recently are less likely to be used in the near future. And also it's the simplest to implement and hence the most popular. So mostly this algorithm looks for the entry that has been the most idle over a certain period of time. Then first in, first out, this one replaces the oldest entry in cache, and it's easy to implement as it only requires a simple queue to manage entries, but it may not be the most effective for all access patterns. Then list frequently used. This replacement selects the entry with the least number of accesses over time. It aims to replace items that access the list. Implementing this accurately can be complex due to maintaining and updating access counts. So that's been it, and I hope you got it well.